I'm going to talk a little bit about the work that I've been doing on crowdsourcing backstories for complex task-based search. And I've been doing that work with Damiano, Falk, and Lawrence, who, yes, are all from RMIT. I would like to motivate the need for backstories by an example. I guess most of you know that backstories are a well-established instrument to represent information needs. And backstories are available for some search scenarios, but not for others. If you consider a typical job search scenario, it is task-based because a job searcher usually looks for suitable job advertisements that fit their information need. And it also is potentially complex because apart from a query, there are other restricting properties that would restrict documents that are relevant to the search, such as the location or a wage range, for example. So I've provided a search query here for a typical job search scenario, which is English teacher. And one possible backstory would be a person that is looking for an English teacher in the eastern suburbs of Melbourne, and that person is looking for a full-time job. Whereas another information need would be somebody looking for an entry-level English teaching position. That person, however, is flexible about the location, and we don't know if the person is looking for a part-time job or full-time job or just a casual job. So based on these two different information needs, you can see that the query English teacher is potentially intent ambiguous, and so the query alone is not enough to judge relevance of documents that are returned by a job search engine. So as I said, backstories represent information needs in written form. So they provide vital contextual information for a search process. They can be used in various different tasks, such as judging relevance as part of test collections or for query disambiguation. And the problem with them at the moment is that they're available for some popular IR settings, such as some TREC tasks, TRECs, whereas backstory collections are missing for other search domains and search settings, especially new and emerging settings such as job search or other similar e-commerce searches. In the work that I'm going to present today, we explore crowdsourcing backstories as an alternative that is potentially more cost-effective than having such information need statements generated by domain experts. And by crowdsourcing backstories, we also potentially increase the variety of backstories that are generated for a single query. Apart from presenting a crowdsourcing methodology, we also provide a job search backstory collection that is freely available for research on GitHub. Now, I quickly want to touch on how user interactions are modeled with systems currently, and probably the most prominent instrument to model user interactions are personas. And these are elaborate system user descriptions where fictive people are generated, which represent a group of similar users that would use a system. And they can be pretty complex, and they can contain additional artifacts such as pictures, like our derp here. And they can contain loads of other information that are potentially not relevant for a single search task, such as a person's or a user's hobbies or family status and so on. And based on these personas, scenarios are created on how these people interact with a system. And these scenarios are mostly comparable to backstories. And backstories, in comparison to personas, are much simpler. They are just short textual statements. They represent a single information need, and they should just contain enough information for the task at hand. So for a specific search scenario, for example. I will now describe our crowdsourcing settings and how we establish the methodology of crowdsourcing backstories based on the example of job search scenarios. We present crowdsourcing workers with a search query and a potentially relevant job advertisement for that search query. Potentially relevant in this case means it was presented in the top 20 results and clicked at least once. And the job advertisement contains various properties such as the location or a work type and salary ranges, as well as a textual description of the job. We then asked workers if the job advertisement is relevant to the search query. And then they had to create a backstory in written form, which represents an information need for job search scenarios. And then the crowdsourcing workers had to indicate how satisfied they were with their created backstory and explain that satisfaction decision. So for developing the methodology, we had workers create 5 backstories for 15 different query and job ad pairs. The queries and job ads were extracted from a major job search platform in the time frame of May to June in 2017. The experiment was conducted on the Figure 8 platform, which was formerly called Crowdflower. And in order to mitigate potential language barriers, we only admitted workers from English-speaking countries to work on our task. Now, we iteratively developed the methodology of crowdsourcing backstories. And for our first iteration, we set the minimum length of a backstory to 100 characters, just so that workers wouldn't submit blank or low effort results. We set the minimum working time to 3 minutes so that we ensured that workers would read the provided information, and the initial pay was set to $50. We didn't employ any additional accuracy checks or worker filtering at this stage. Now, off the bat from the first iteration, we gathered 70% usable backstories, and by usable backstories, I mean text snippets that represent an English text structure and that exhibit a job search information need statement. Now, these text snippets can contain minor punctuation or grammatical errors. The main problem with this first iteration were that backstories were written from a hirer's perspective, and some backstories were just copy and pasted text from the provided information. So after this first iteration, this was my phase. It was like, okay, I think we can do better. So for the second iteration, in order to mitigate the problem to get backstories from a hirer's perspective, we provided improved instructions to the workers. We employed some JavaScript so workers wouldn't be able to copy and paste text into the text areas. And we also employed a substring detection of text that was entered into the backstory input area to prohibit submissions that would just be text that was present in the job ad. Based on the workers' feedback, we increased the payment to $65 per task. And so the second iteration surprisingly only yielded 63% usable backstories. And the main problem with this run was that people from 11 accounts submitted what I call meaningless backstories. And this was a template that was submitted which exhibited a combination of a hirer's and job seeker's perspective, but the template was filled out with slight variations so that the submissions would still be unique, but they were unusable as job seekers' backstories. So this was either a single person doing that with 11 accounts or just people sharing information. So since the usable backstories dropped, you could imagine my face. I wasn't really happy about that. So in the final iteration, we employed worker accuracy checks by an so-called initial quiz mode to filter workers before they could even start on our experiment. And we also, for continuous accuracy checking, employed so-called gold rows, where a predefined answer is known that can be compared to workers' answers. And the question we used for that was if the job ad is relevant to the query. In order to make this work, we had to increase the amount of tasks per page to 2. Due to this now accuracy checking in place, we could then also enable a larger worker pool with lower confidence level. And since we have 2 tasks on a single page, now we can compare the 2 backstories on a single page to make sure that they are dissimilar. And in order to check this, we decided to use a Levenshtein similarity of the 2 backstories, and the similarity needed to be below 0.65. In order to entice more elaborate backstories, we increased the minimum character length to 200. And this run yielded 91% usable backstories, and all the remaining unusable backstories were some that were written from a high-res perspective. So that was good enough for me. So I was happy with that. Here are some example backstories that were obtained via the final iteration. And in general, they contain enough information to be useful for further tasks, such as relevance assessment. Generally, they were short in length towards the low set limit of character length. And they were also mostly quite similar to the examples that we provided the crowdsourcing workers, although there were some more creative ones in there, but rather far in between. This figure shows the fraction of backstories for each of the iterations. As I already said, in iteration 1, the main problems were backstories written from a high-res perspective and copy and pasted text. And in the second iteration, the main problem was submitted templates with slight variations. But the good thing is that in the third iteration, apart from the 91% usable backstories, the only category of unusable backstories we identified were some that were written from a high-res perspective. So I would assume if the instructions were improved further, that 9% could even be reduced further. I have some descriptive statistics of the 3 iterations as well. And the interesting part here is that with all the additional checks in place for the third iteration, the mean task completion time wasn't really hampered. The task completion time was similar to iteration 1 and 2, despite a lot more workers taking up the task. And by the increase in workers, that could also be an indication that the methodology works as intended. So based on the settings of the third iteration, we created a job search backstory collection of 756 backstories for 50 queries. And the interesting thing in this table is that the average task completion time went up a little bit again, potentially meaning that workers took the task seriously. So in conclusion, we established a crowdsourcing methodology for creating backstories for complex task-based search settings with the example of job search. We got about 91% usable backstories in our final run. And the elements of our methodology might be transferable to other similar domains, such as real estate or automobile sales, so other e-commerce search settings. We provide a job search backstory collection on GitHub, consisting of 756 backstories that we crowdsourced over a time frame of 5 months. Now, compared to having backstories created by experts, that might be a long time frame, but it really doesn't require any effort on the search provider's part. You can just add new rows to the experiment if you want more backstories, and just leave it there and have crowdsourcing workers churn out new backstories. And this might be obvious, but if you're going to spend a bunch of money on a crowdsourcing experiment, it is quite highly recommended to test your experiment on a small scale first, especially for more complex tasks like creating text snippets in our case. Future work will include assessing the usability of backstories for further tasks such as relevance judgments, and also automated quality assessment of generated backstories. Furthermore, investigation of the methodology for other task-based search settings would be interesting. The resources are available on GitHub under this link. And I would like to acknowledge the Australian Research Council and SEEK for supporting this research project. And to close, I will present my own backstory. Since I'm in the finishing stages of my PhD, I'm looking for employment opportunities, and my interests include information retrieval, data analytics and manipulation, and software development and related areas. If anybody is interested in talking to me, you can contact me via this email, mail@link2.ms, or on Twitter. Thank you.